Okay, so this is going to be a long one because I want to go through this test review with you, but hopefully it'll help you. So this is the paper that I gave you yesterday. These are things you need to know how to do, and so I kind of just went through it. If you want to go back and look at the sections, um, this was 5-1, this was 5-1, this was 5-2, this was 5-3. The ways to factor, you definitely want to look about that. This was 5-3 as well. And then we ended this with imaginary numbers. And so all of this is from 5-4 and then just some vocabulary. Most of the vocabulary shows up in the directions of understanding what it's asking you to do. So this is the review assignment that you were supposed to be working on in class today. These are the assignments with notes that you should have to turn in to me tomorrow. So 5-1 and 5-2 we just spent one day on. And then 5-3 we had day 1 and day 2 notes and homework. And 5-4 we had day 1 and day 2. And then this review assignment. So make sure you have that together to turn in to me tomorrow. And I'm just going to kind of go through this here with you. And then you can ask questions as we go. State whether each sentence is true or false. If false, replace the underlined word to make a true statement. It says the factored form of a quadratic equation are here where a, b, and c are integers. No, not factored form, so that's false. That should be standard form. The graph of a quadratic equation function is called a parabola. That is true. The axis of symmetry will intersect a parabola in one point called the vertex. That is also true. The number 6i is called a pure imaginary number. That is also true. A complex number is when it's like 7 plus 6i, where there's a real part and an imaginary part. And the two numbers 2 plus 3i and 2 minus 3i are called complex conjugates. That is also true. So those are just some words that I think you should know. So it says complete parts A through C, find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Make a table of values and use this information to graph the function. So number 9 is f of x equals x squared plus 5x plus 12. So the first thing that I'm going to do is I'm going to find the y-intercept, because remember the y-intercept is where it crosses the y-axis, and it's when x is 0. So if x is 0, the y-intercept is always just c. To find the axis of symmetry, it's the equation x equals negative b over 2a. So remember that the number in front of x squared is a, b, c. So that would be negative 5 over 2 times 1, or negative 5 halves. Sorry, I was about to do the decimal. Or negative 2.5. And then the vertex, remember, is the ordered pair, the point that goes through that axis of symmetry. So the vertex is also negative 5 halves. I'll say negative 2.5. And then I have to plug that back in to find the y value. And so I got to do that really quick. Be careful using your calculator. Remember to put it in parentheses when it's negative. So negative 2.5 squared plus 5 times negative 2.5 plus 12. And I get 5.75. And so if I'm going to graph this, remember that I don't even need, I don't think I need an XY chart necessarily. You can make one if you want, but I'm going to show you this really quick. If I was going to do this, I'm going to do my vertex, which is negative 2.5, 5.75. 1, 2, 3, 4, 5.75. So I'm going to say that's roughly about right there. Remember that the axis of symmetry is the line that cuts right down through there. Well, I've done moved that. 3, 4, 5. Sorry, I moved my graph and now it's moved. 1, 2, 3, 4, 5.75. I think it should be right there now. And then I could use my y-intercept, which is 12, but 12 is off the graph. So I could also use the 1-3-5 rule, right? So if I'm here at 2.5 negative, I could go over to negative 1.5 and up 1 on each side. And then I could go over 1 again, and I could go up 1, 2, 3. Over 1, up 1, 2, 3. And it would sort of look like this. And so remember that if x squared is positive, it opens up. If x squared is negative, it opens down. And you can use the 1-3-5 rule to help you. Okay? So I'm going to start number 12 here, and then I'm going to end up erasing this. But number 12, the y-intercept is c, which is -1. I notice right away this is negative, so make sure you keep that in mind. The axis of symmetry is x equals -b over 2a, or in this case, that would be -12 over 2 times -3. -12 over -6 is +2. So when I plug that back into the problem, that would give me -3 times 4 plus 24 minus 1. -12 plus 24 is 12, minus 1 is 11. So I think my vertex, if I did that correctly, is 2, 11. So if I was going to graph this, I'm going to erase this part. So now my vertex is at 2, 11, which would be like up here. And then I can't just go down 1 over 1 on this one. I am going to go down because it's negative. But the 3 means that the 1-3-5 rule is now multiplied by -3 if you want to think about it, which means now instead of going over 1 and up 1, I could go over 1 and down 3. And instead of going over 1 and up 3, I would actually go down 9. So over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it would flip over this way. And if you notice, that was my y-intercept down here at -1. Remember that these should be smooth curves, so it should look something like that. But remember, if there's a number multiplied in front of your x squared, it changes the shape of your graph. Something else you're going to have to do on your test is just like this. I want to know if it has a max or a min, and then I want you to find that value and state the domain and range. So, number 13. The fact that it's negative means it opens down. So that means that it should have a maximum. Where does that maximum occur? It occurs at the y value of the vertex, not the x. It's the higher low point. But you got to find your x value first. So you have to do -b over 2a. Or in this case, that would be -3. And 2 times -1 is -2. So that would be 3 over 2 or 1.5. That's the x-coordinate of my vertex. That's like my axis. I need to find the y-coordinate. So I need to plug that back in. And again, you want to use your calculator correctly. So if you do that correctly, you should get, make sure you put the 1.5 in parentheses. 1.25, I believe, is what I got, or 1 1/4. That is your max value. So the maximum is at 1.25. And then the domain and range, remember, because this is a smooth continuous curve, the domain is all real numbers. The range starts or stops at that max or min. So since this one's opening down, it means that the range goes down forever. So it's -infinity up to 1.25. If it opens up, it would be 1.25 to infinity. Okay? Okay. It gets faster after those first ones. All right, solve by graphing. So I only gave you one of these, but remember if it says solve by graphing, solve means find the solutions, which we also did by factoring as well. But if I'm going to graph it, I'm going to do one more graph here. On number 17, my y-intercept would be -3. My axis of symmetry would be x equals -b. So in this case, that would be +1 over 2 times 2, or that would be 1/4. So if I plug 1/4 back into that problem, this is not going to be very pretty. 2 times 1/4 squared minus 1/4 minus 3 is -3.125. So if I make a graph here, and I'm just going to make a, oh, that's really not what I wanted. If I make a graph here, I'm looking for where it crosses the x-axis. So I know it's at 1/4 negative 3.25. So that's really, really small like this, right? And if I has a 2 in front of it, so I can't just go over 1 up 1, but I could go over 1 up 2, over 1 up 2, right? And my y-intercept is negative 3, so that doesn't really help me a whole lot either, right? Why does this keep switching on me? My y-intercept is right here, so that doesn't really help much. But if I just kind of wing it a little bit, it looks to me like this doesn't cross at a nice point. So I would say it crosses between 1 and 2 and between 0 and negative 1. Now, if this were factorable, we could factor it and check the answer a lot quicker. And I'll show you that on the factoring ones in a minute, that maybe it crosses at an exact point that we could factor it and we could see exactly those answers. Okay, but that's what it means to solve by graphing. Find the x-intercepts. Definitely you're going to have a question like 20 and 24. We did a few like this. Some people did this for their Flipgrid. But if I give you the zeros or the roots, right? So on number 20, that's a 0 or a solution of 5 and a solution of 6. I want you to go backwards and write it as the factors. It does say write an equation, so you need to say equals 0 or equals y or equals f of x. And then in standard form means no fractions, no decimals. So if I multiply this out, I get x squared minus 6x, right? That's this, and then minus 5x and minus 30. So combine the like terms in the middle, and I get x squared minus 11x minus 30 equals 0. And what is that saying? That's saying this equation would cross the x-axis at 5 and 6. The ones that we did in class had fractions in them. So let me remind you how to do that, because I'll guarantee the one on your test is going to have that as well. So step 1, I multiply by 6, and I get 6x equals 1, because I want to get rid of my fraction, right? So whatever's in the denominator, multiply it over, and then I can subtract that over and get 6x minus 1. And on this one, I just subtract the 5 over, because there's no fraction, and that would be x minus 5 equals 0. Then you multiply that out, so you get 6x squared minus 30x minus 1x plus 5. And just like the other one, you can combine the middle terms. So you get 6x squared minus 31x plus 5 equals 0. That equation has the solutions 1, 6, and 5. So 100% you're going to see a question like that. All right, so if it just says factor tomorrow, if there were no equal signs on these problems, right, I'm going to show you what they would be, and then I want to show you the difference of when it says solve, okay? So on 26, I gave you the harder ones to factor here, but the first thing I noticed on 26 is I could factor a 2 out of that as a GCF, so don't forget about the GCF as an option. And if you could factor the 2 out of there, when there's just an x squared here, right, that's usually the type of factoring that we like, because we say what multiplies to give me x squared? Just x and x. Then you have to think, what multiplies to give me negative 12 that subtracts to give me negative 1? Well, your only options are 1 and 12, 2 and 6, or 3 and 4. And only 3 and 4 subtract to give you negative 1. And to get a negative 1, it's going to have to be a negative 4 and a positive 3. So you need a positive 3 and a negative 4. If the direction said factor only, if there was no equal sign here, that's it. That's the factors, right? But since this says to solve it, now we set each part equal to 0. Well, this 2 out front doesn't have an x in it. So like if you set that equal to 0, that doesn't equal anything. So if there's ever a GCF out front that's a number, you can just ignore it. Then you're going to set this equal to 0. and this equal to 0 to get your solutions, your zeros, your x-intercepts. So you get x equals -3 and x equals 4 as your answers. You also are definitely going to have one or two that you have to do the rainbow method. This does not have a GCF, so you have to multiply the 2 and the -3 together to get -6. And then be really careful, because this sign right here determines whether you're going to pick 2 and 3 or you're going to pick 6 and 1. Since you're subtracting to get -5, you're not going to pick 2 and 3. You're going to pick -6x plus 1x, because -6 plus 1 is -5, and -6 times 1 is -6. And then remember, you bring down the first and the last numbers, and now you're going to group them together. You're going to group these two together and factor out a 2x, and you're left with x minus 3, plus, if you take a 1 out of that, you're left with x minus 3. So there's nothing in common there. Why did I take a 1 out? Because I need these to be the same, and you always have to take something out. So even if you aren't changing anything, you so I put the parts together that are out here. I take out the x minus 3 that's together. Those are the factors. Now when I set each part equal to 0, I get x equals -1/2. And over here, I just get x equals 3. All right, so factoring is going to be a good amount of this. And then the last stuff is the imaginary number stuff. So just kind of going through these really quick. The square root of -8, you could break that up as the square root of 4, the square root of -1, and the square root of 2. So that would be 2i square root of 2. No plus or minus, because there's no equal sign, okay? This one, pay attention whether it's adding, subtracting, or multiplying. Do not multiply in all of these. We're just adding. So 2 plus 13 is 15, and -1 plus 4i is plus 3i. That's it. You're just adding. This one you're subtracting, so be careful, because that would be subtracting 4, but subtracting a -3i would actually be plus 3i. So 6 minus 4 is 2. 2i plus 3i is 5i. And then this one has no sign in between it, so that one is where you're going to FOIL. So 6 times 3 is 18. 6 times -2i is -12i. 5i times 3 is 15i. 5i times -2i is -10i squared. And remember that I squared is -1, so that's really plus 10. So 10 plus 18 is 28. -12i plus 5i is 3i. And you can't add those together, so that's your answer. And then the last thing you're going to have is solving these equations. So 35, the first thing that I would do is I would subtract 50 over to the other side. I would divide by 2, and I would get -25. Take the square root of both sides, and I get plus or minus 5i. Because it's plus or minus, the square root of 25 is 5, no square root sign, and then the -1 is what gives me the I. 38, the first thing I'm going to do is subtract 16 to the other side. Divide by 8, and I get x squared equals -2. When I take the square root of both sides, I can take the I out, but the square root of 2 is not a perfect square, so it has to stay under the square root. And 39 is 4x squared plus 1 equals 0. So the first thing I'm going to do is subtract 1, divide by 4, and I get -1/4. And when I take the square root of that, I get plus or minus I, well, I'll just, the square root of 1/4, the square root of 1 is just 1, the square root of 4 is just 2, so that's just 1/2 I, or I 1/2, or 0.5 if you want. All right, so that's the kind of stuff you're going to see on your test. So